We complete Chapter 6 of Young and Freedman's University Physics with the treatment of power. We know that force times distance equals work, and that the measure of work is the joule, which is also in Newton meters. Work then times time, or work per time, work divided by time, that is the unit of power. So work says nothing about how long it took or how quickly you did the work. It's simply a product of the force times the distance. It doesn't say how long it took to do it. Power is then the amount of work done per unit of time. And so the watt is the unit for power, and it is the same as joules per second. So 1 joule of work done per second is 1 watt. Here are the relevant formulae. So the average power is simply going to be the change of work divided by the change of time. The instantaneous power is then going to be the limit as delta t approaches 0 of delta w delta t, or the derivative here, the derivative dw dt. Another way of thinking of it is the dot product of the force and the velocity. The reason this makes sense is because velocity is meters per second, and force times meters is work per second is work per time. And so if you take the force as it is incident on the object, so the force as it is the component of force that is parallel, that is to whatever you're talking about, times the velocity at that point. So it might be f cosine phi times the velocity, for example, is going to end up being the power as well, another way of formulating it. So those are the relevant formulas for power, which is work done per second.